Okay, so we have to initiate our new chapter named Indefinite Integration. Okay, so this chapter is very important when it comes to mains and advance. Okay, now you may observe that from this chapter we have very less number of questions which appeared in mains as well as advance in previous years. So you may feel that this chapter may not be that much important, it doesn't require that much of attention, okay, and effort, but I would suggest you to invest good amount of interest into this chapter, because the ideas which you will be studying over here, you will be exploiting those ideas, means you will be overuse those ideas in upcoming chapters, like definite integration, which is super important, differential equation, super important again, area under curve, super important again. So these ideas will be required over there as a prerequisite informations. Okay, so you have to understand this indefinite integration. So what is the symbolic representation of indefinite integration? Try to understand. So we will be using this symbol. Okay, so what is this symbol? First, try to understand this is representing integration of f of x. So function in x, and you guys are integrating with respect to x. Okay, so if you will differentiate, you will get some answer with a constant. Means I will explain you uh, after some time. Like suppose that you know that this is indefinite integration. Now, so we call this chapter by using some different names as well, like reverse of differentiation. Okay, so it is opposite of differentiation, or you can also say that antiderivative. Okay, so this is antiderivative. Also you can call it as primitive. Primitives. Okay, you can call like suppose that if I am interested in finding primitive of sine x, means I want you to integrate sine x. Antiderivative of sine x means I want you to integrate sine x. Reverse of differentiation, this means I want you to find out the reverse of differentiation, means I want you to find out the integration of sine x. Okay, now look at this. Like in earlier days, we guys have studied addition. So do you know that its opposite is subtraction? And same way, opposite of subtraction is addition. Then we have studied multiplication. The opposite of multiplication is division. And you also know that opposite of division is multiplication. So same way, differentiation opposite is integration, and opposite of integration is differentiation. So this is the idea about this chapter. Now, the things which you have studied in the differentiation, like formulas, some results, so you will be using those results over here. Means I used to give you some question and then you used to differentiate it to get the result. Now that result will be integrated over here to get the question. Okay, so I will try to get through those formulas one by one. So suppose that we have x power n, and that has to be integrated. So suppose that if you wish to integrate, you will have integration as x to the power n plus 1 by n plus 1 plus integrating constant. This integrating constant is super important to place. For example, suppose that I have given you to integrate like, wait, I'll give you differentiation. Suppose that I want you to differentiate x power 5. Okay, so you know that you will be writing 5 x power 4. This means if we will integrate this function, we must get this function, correct or wrong? So let's integrate 5x power 4 with respect to x. Now this dx defines the integration has to be done with respect to x, and everything except x becomes constant. Now try to integrate this function. So it is 5 taken outside. Now x to the power 4. So apply this formula. So it will become x to the power 5 by 5. है ना? This thing gone. Now you know that I have placed integrating constant over here. Now look at the significance of that integration constant, why it is required. So suppose that I have given you to differentiate x power 5. What if we will give you differentiation of x power 5 plus 10? You know that again you will get 5x to the power 4. So if you will integrate this function, you should get this function. But if you'll integrate without it putting integration constant, you cannot reach that situation. Okay, so that makes integration constant to be placed while handling integration. So integration of x to the power n is this. Now, if this n is minus 1, then you cannot apply that formula because this thing will become 0. Okay, means denominator will become undefined. So if x to the power minus 1 is given, this means 1 by x, you know that its integration will be log x plus c. Okay, like you can connect with that one. What is the differentiation of log x? Log x, differentiation of log x is 1 by x. Therefore integration of 1 by x will become log x. I hope this was okay. Now what is integration of e power x? Same thing. If you will differentiate e power x, you will get e power x. Now what is the integration of a power x? So integration of a power x is a power x by log a plus c. So first you have to deal with this set of formulas. Now we will move on to the next set of formulas, and then you have to come back again to revise this set along with that one. Then next set, revise everything. Then next set, revise everything, and so on. You have to revise these formulas on daily basis, because in this chapter you will be learning so many concepts and so many ideas and so many formulas. So to hold command over those aspects, you have to revise a lot. Okay, if you will forget a statement, you may end up losing control over n number of questions. Okay, so you should have good command over revision part. Okay, let's move on to the next part of formulas. So now we have to deal with these trigonometric formulas. So differentiation of sin x. If you will try to recall integration of sin x, if you will try to recall, in differentiation we used to differentiate, correct? We have memorized so many formulas over there. If the question is in c, we used to put extra minus into the answer, correct? So here things will be opposite. If the answer is in c, you have to put extra minus. Okay, so what is the integration of sin x? Sin x is cos x plus c. Answer is in c, put minus. Integration of cos x, sin x plus c. Integration of tan x, log mod sec x plus c. Integration of cot x, log mod sin x. Why I am putting mod? Because You know that sec x and sin x can be positive, negative, but the argument of log has to be positive. To keep that thing intact, we put mod sign. Now, sec x integration is log mod sec x plus 10x plus c. Integration of cosec x log cosec x minus cot x plus c. Okay. Now we have sec square x. So sec square x is 10x plus c. I will require some space. Okay. So we have cosec square x. Okay. So cosec square x is, wait a moment, cot x plus c. Now you know that the answer is in c, so we will put minus. Okay. So the idea is like we have sec x 10x. So integration of sec x 10x is sec x plus c. Now cosec cot is uh, cosec x, yes, cosec x plus c. Again answer is in c, so we have to put minus. So next round you have to hold command over these formulas. First, you know that you will be comfort, like you have to handle all the trigonometric terms, means sine cos tan cot sec cosec. In this two term, sine cos cos sine, and in remaining thing you will be having log. Okay, so log you have to handle carefully. Is that okay? Now, in remaining part, you have square, square, sec x, tan x, cosec, cot x. So you have to handle accordingly. Then come back again to revise everything of set number 1, then set number 2, and then move on to the next set of formulas, which is this. Now, if you will try to recall the differentiation of sine inverse x, you will get this result. So differentiation of sine inverse x is this. So integration of 1 by root over 1 minus x square is sine inverse x plus c. Also, you know that you can use minus of cos inverse x plus c. Okay, so differentiation of cos inverse x is what? Minus of 1 by root over 1 minus x square. So you can use here. Answer is in C, so that's why we put minus. Now, try to recall the differentiation of tan inverse x. So it is integration of dx by 1 plus x square. So it is tan inverse x. So tan inverse x plus c. Now, what is the other formula? It is cot inverse x plus c. Okay, answer is in C, so put minus. Now, this was what? Sec inverse x plus c minus of cosec inverse x plus c. Okay, now you have to connect these formulas with the upcoming formulas. Okay, now you have so many cases, means now again you have to go back and revise everything. Now look at this set of formulas. So it is dx by without root, something square, something square. This is dx by with root, something square, plus or minus combination. Okay, then this is on the numerator and everything is under the root. So first try to hold command over these two situations. So first situation is dx by something square plus or minus something square. Now try to connect this explanation with the previous explanation. So if you'll observe, in two of the formulas we have root, and in one formula we don't have root. So here we don't have root anywhere. So I can connect without root wala formula with without root wala formula. Means if I will be having these kind of question, I'll be asking you dx by without root something square plus or minus something square. Then I'll be asking you guys whether you guys are comfortable or not. So if you are comfortable, then you will connect with the previous explanation. Okay, if you are not comfortable, then you will be using log. So in these three sets, you are comfortable over here and you are not comfortable in above two cases. So use log. And this comfortable formula reminds you of what? Reminds me of tan inverse x. So here you will be using tan inverse. Okay, now if you are comfortable, wait a moment, I missed one point. Okay, so if you are comfortable, tan inverse x. Now again you are comfortable or not? So in third formula you are comfortable. So if you are comfortable, 1 by a. If you are not comfortable, 1 by 2a. Okay, now here if you are comfortable, tan inverse x by a plus c. Answer is done. Now you have to put mod, because you know that inside the argument of log you should have positive things. So look at this. If x is bigger, so x is bigger, x minus a by x plus a. If a is bigger, if x is bigger, x will be placed in the numerator. If a is bigger, so a will be placed in the denominator. A minus x will be placed in the denominator. So a plus x. Then plus integration constant plus integration constant. Okay, so this way you have to memorize. I will ask you these questions so many times in the during the session, but try to memorize here only. Now we have second set of formulas. So it is in the denominator with root something square something square. So if in the denominator we have something square, it reminds us of what? This first situation. Like look at this, you have something coming outside. So if you'll observe there, you will never find anything coming outside in the question. Look at this, nothing is coming outside. So you will fall in the first case, correct? Means that one sine inverse x. So again I will be asking you guys whether you are comfortable or not. So in this case you guys are comfortable at this case 1 minus x square. If x is a is 1, so it will connect you with sine inverse. So if you are comfortable, use your comfortable formula, sine inverse x by a plus c. And if you are not comfortable, you will be using log. If you are not comfortable, you will be using log. You know that if we have to use log, we have to put mod. Okay, now so log with what? X plus the question, root over x square minus a square. So if it is log x plus question, root over x square plus question. Okay, and then put integration constant. This integration constant is important. Okay, later I will explain you how to find out the integration constant as well, but for time being you have to hold command over this. Okay, now look at this formula. Okay, so again you have to connect with this set of formula only, these three things, and you have to ask yourself whether you are comfortable or not. But for time being, just wait. So in every formula you have to write x by 2, x by 2, x by 2. So first thing is x by 2, correct? Now next thing is you have to write down the question. Root over x square minus a square, question. Root over a square minus x square, question. Root over x square plus a square, question. Okay, now you have to get focused on a. So if, look at this, here a is negative, so negative of a square by 2. Here a is positive, so positive of a square by 2. Here a is positive, so positive of a square by 2. I'm trying to connect some relationship with the explanation, okay, so that you can memorize these formula. Okay, this has been derived in different way, but you have to memorize this way only. Okay, now among these three set of formulas, first you have to connect with to which formula you are comfortable. You know that you will connect with the first three, this three set of formulas. Okay, so over there everywhere we have root, है ना, in the numerator. So root is over here because in that question nothing is coming outside. Okay, so we will connect with the first one, means sine inverse. Okay, so if you'll observe these three formulas, in the middle formula you guys are comfortable, so use your comfortable formula. So it is sine inverse x by a plus integration constant c. If you are comfortable, use your comfortable formula. If you are not comfortable, you will be using log. Okay, log. Inside log, what we will write? We will write x plus question, x square minus a square plus c. If you are not comfortable, we will write x plus question, x square minus a square not c. Okay, so this is these many formulas. Please revise, please revise a lot, as much as possible. Okay, now we have this formula, integration of two functions. So suppose that if two functions are written in addition, you can separate them and you can solve them separately. Subtraction, you can apply that one. Multiplication, here is the formula. Now the formula is you have to like use the statement which I am using. Okay, so you have to write first function, u is the first function integration of second function minus whole integration differentiation of first function integration of second function. Okay, this statement you have to use. The statement is first function integration of second function minus whole integration then differentiation of first function integration of second function. Okay, so this statement you have to repeat n number of times. Okay, now So it is first function, integration of second function, minus whole integration, differentiation of first function, integration of second function. So this you have to memorize. Now, if two functions are given in product, then how we will decide that which function has to be taken as the first and which function has to be taken second. So why this is important? Because if mistakenly suppose that if you will take a function to be first function which has to be taken as second function, okay, and you will try to integrate, you will keep on integrating till infinity and you will never get the proper result. Okay, means the time consumption will become greater and it will require lots of time to solve those questions. You will like you will take days. So you have to pay attention to the parameter that which function has to be taken first, which function has to be taken next. Now, to resolve that problem, you have to take help of this idea. I late. Okay, so this word is important, I late. So what does this I stands for? I is inverse. Inverse function, sine inverse, cos inverse, tan inverse. Okay, so you have to, if inverse function is there in the function, you have to take it as first function. Then L is logarithmic function, A is algebraic function, T is trigonometric function, E is exponential function. Okay, exponential function. So if these function will come, suppose that you got inverse and trigonometry, inverse trigonometric function and trigonometric function. So you will keep inverse function as the first function. So priority will go this way. Okay. Also you have to memorize this function, this part. Okay, this part is super important. If you will get trapped in some question, this statement will help you like a savior. So this statement you have to memorize. Now suppose that right now if I'll ask you, according to you guys, which chapter is easy, differentiation or integration? You may answer that, sir, differentiation was easy, because you guys have already studied differentiation, you guys have solved so many questions. So with time you have built greater understanding about the differentiation. So look at this. For a function, if its differentiation is easy, okay, take it as first function. Okay, and if its integration is easy, take it as second function. Okay, so this thing will help you a lot. And your first filter should be this, your second filter should be this. Because you may argue with me that, sir, if I'll talk about logarithmic function and algebraic function such as x square, so both function differentiation is also easy and also integration is easy because it is direct formula based. So in that case, what we have to do, you should always go with this first apply eyelet, then if you will stuck, you will be using this situation. Suppose in some situation you are getting so much trouble that we are not able to convert the question, then you will be using this note. I hope You got little bit of understanding about the formulas, how you will have good command over these formulas. I tried, but I want you to memorize these things so that it can help you to solve n number of questions with great efficiency. So let's move on to the illustrations part.